So what I'm about to show you is network bending. It is a neural synthesis technique that is about accessing the weights of the neural networks and modifying them live while generating sound. I have done a workshop on this in the past, and I think I'm gonna probably repeat it in the future. The workshop introduces some theory, talks about the neural nets and also about the concept behind. In this case, in this online video, I'm not gonna really go through the theory. I'm gonna make it super practical. So in case you're interested in the theory, I'm gonna leave some links like this little article that I have written about it, and also a link to the guide that basically gets you through the same thing, but in this case a bit less extensively. So yeah, I'm gonna try to get through the entire process together. So what you're gonna need, just as a disclaimer, maybe this kind of assumes some previous experience with pure data and some familiarity with neural synthesis and some of the popular models like rave, for example. Anyways, I'm gonna be talking about it in the process, so let's just get onto it. The first thing that you need is pure data. And I have downloaded the pure data already. You need at least the version 0.54. I'm unpacking it here. Just confirming that it works. You have to allow it to start. Yeah, so it works. Now I have this little patch to start with that you should be able to access. It starts, which is a good sign, but what you can see is that it cannot load this NN neural net object, so we're gonna have to install it. The link to the object, to the external, is here. I'm gonna leave it, I guess, in the description of the video. This external allows you to load neural networks into the pure data. That's long story short. And this external is based on the one created by the ACIDS team at IRCAM, but I have modified it slightly so it allows for for network bending. It is here on my GitHub repository, but you also have a link to download directly here. So I already downloaded it. It is here. I unpack it, and then in order to install it, you basically go to your pure data library. In my case, it's here, but so home directory library PD, but I think in your case it might be a bit different. I just take the content of the unpacked archive and drag it into here. What I do next is I restart the pure data and I try to open the patch again. What's gonna happen here is that Apple is gonna have a problem with this external because it will think it's malicious. So we're gonna have to go to the settings, and in the security, I believe, privacy and security, when I click OK here, it will give me an option to allow opening the software. We're gonna have to do it multiple times. It's a bit annoying, but that's the most straightforward process. I think there are other ways to do it, but I think this is most straightforward to explain. So we just have to keep repeating this process, restarting the pure data and starting the patch every time. And more of the extensions will appear here. We just always have to allow them to start until until the pure data patch basically starts correctly with no errors. So far we still have issues, but just trust the process. It's really all about the repetition here. So yeah. Okay, as you can see now it has loaded, which is a great news. So what we have here in this simple patch is basically we have the neural net external loading model that I have created. More on this later. And it allows us to load a sample. The sample patch is here. It basically lets us choose the sound, and then it places in a loop. Place the sound in a loop. Then we have a simple crossfade here between the sample and the style transfer version of it. Here we have a fader that allows us to choose. On the left we have a sample. I think on the right is gonna be the neural network, the model version of it. And here we have volume. A pretty simple patch. So we can choose a sample here. I'm gonna start with something percussive. Remember, you have to start the DSP, and we can increase the volume here. So we hear the sample right now, and then when we crossfade, we basically get we're gonna start hearing the neural network, the model reconstruction of the sample, right? So this patch should work for you. That's just to kind of get our feet wet a bit. This patch demonstrates the basic capabilities of the NN external. So the NN external takes the sound in, processes it through the neural net, and outputs the processed sound. Until that far, this is the feature set of the NN that was provided with the original object. So the one provided by ACID's team in IRCAM. What I want to demonstrate in this simple patch is the extension of this external that I have implemented, that basically exposes the weights of the neural network layers. So again, here I'm not gonna get very deep into the explanations, but just to have like a very basic idea in case you don't really have it clear what weights and layers am I talking about. Neural networks normally have multiple layers of processing. What happens within neural networks is basically that the sound gets transformed into numerical representation, so like a bunch of numbers basically, and then these numbers flow through many connections, multiple layers, where each node is basically a numerical representation of some part of the sound, and it gets transformed through this many layers. Here we only have one, and the connections between these nodes within the network are represented by numbers. These numbers are weights and biases. So basically the takeaway from this is that there's a bunch of numbers in the neural nets, and these numbers are pre-trained, and they basically kind of define the identity of the network or the model and its capabilities. And once you start screwing around with these numbers, the network starts misbehaving, and this is basically what we are trying to do, to make the network kind of glitch out and produce unexpected results. So the extension of the neural net external that I created allows you to access these weights, and in order to access them, there are 3 commands. This commands, I'm gonna mute this for now. This commands you send in form of messages to the first inlet of the object, and then you get the responses on the last inlet of the object. The first command to know is layers, and this basically makes the network print all the available layers in the network, or return all the available layers of the network so we can print them. So if we connect this method, this command to the first inlet and print the output, that's what we're gonna get. I know it's pretty messy, but what is important to understand is that it's like separated by spaces. We have all the names of the layers available in the network. The spirit of working with this technique is that you kind of don't really need to know what these layers do, but you just need to know how to access them, right? And then you can just play around and kind of, experimentally arrive to the results. So we have now all the names of the layers, and the next command that I want to show you is how to get the weights of these layers. So to get the weights, we basically have another command that's called get weights, and here we need to put the layer name. So we can choose whatever layer name from those. Let's just go with, for example, this one. I copy this and I put it in the place of the layer name. Now, when I send this to the network, it's gonna provide me on the output all the weights of the selected layer. It's gonna be a lot of weights, and we want to store them somewhere. So what I do is I create an array where we're gonna store them. I'm gonna call it weights. The size is not relevant. We're gonna be modifying it at every command. So I have this array here, and now I want to save. I want to save the weights into this array, right? So first of all, I'm gonna just do a little routing here. I do this because the output for the first command, the layers, starts with layers as well. So if we route this, we can kind of route it to the printing action and make sure that we're printing only the list of layers and we're not printing the weights. What we want to do with the weights instead is we want to store them into the array. In order to store it, what I do is I just send this to the weights into two commands. One is gonna get the length of the received list, and it's gonna, according to this length, set the size of the of our array. And then the second thing we're gonna do is right after we set the weights is we're gonna set the weights, or we're gonna store the weights. I think this should work. So now we try to get the weights. Okay, we've got them here. As you can see, we can choose some other layer just to see that they actually do change when we change the layer. So here we are receiving all the weights that we can screw around with. Now, next command that we now need in order to bend this to bend this network is to, when we play with these weights, we then want to be able to set them back, right? To update the network with the new weights, because that's all what this technique is about. For this, there is one more command that is called set weights, and then here we get layer name and then the list of the weights, of the new weights. So what we want to do is basically set the same layer name as the one that we got the weights from, and then we somehow want to append the new weights to this command. So in order to do that, we remove this for now, and let's create a bank object that will update the network. Then we will first get the weight. So first of all, we will need the list append in order to create a full command. So we start with this, and we want to append to it the name of. We want to append the list of weights, right? So in order to get the weights, we have this command get weights. So we get the numbers from the array, then we connect them to the second inlet of the list append in order to set what we're going to be appending, and then we are sending this message. I think this should construct the correct message, and then we just have to remove the symbol because the message is going to start with the symbol. And this we can connect to our network. So let's listen to the results now. This is a non-bent network, right? So once again, let's get these weights. Now let's modify something here, and let's set the new weights. Right, it works. You see, it already kind of modifies the behavior of the network. No, so if we go on, the network is gonna basically continue to deteriorate, and that's what we are interested in somehow. Yeah. Let's try another layer. Here, this is the weights we have. Let's remember to set this to the right one. Send again. Let's see what happens. Sometimes it can be quite unpredictable, so I would recommend having some limiter. I have limiter in the Ableton where I am recording this. But as you can see, we kind of start to get, and there is a command that is built into the original NN object that allows it to reload. So every time you get too far, you can just reload the network and get all the layers back to the original state. So that's the basic idea, and that's like the most basic implementation of it, right? So now we can move on to the more complex play. I have this patch that I'm also gonna share with you. That is the one that I was using for the workshop that I have originally gave. Okay, it looks a tiny bit more intimidating, but it basically It basically implements all the same ideas, just in a bit more playful way, and it has some extra features that allow you to actually play and perform with this. So let's just start right away. I'm loading another model here. There is gonna be a rave model in this case, because the previous one was like a little dataset model based on the DSP architecture that I'm working on. This one uses the VCTK model that is trained on a rave architecture. It's I think vocals model. So once again, we have the DSP on. We have volume here, as you can hear. It kind of sounds like a vocal drone. Additionally, here I have this latent code transport sliders that basically allow you to move within the latent space by offsetting. So it allows you to like kind of an unconditional generation that is not driven by any sort of sample, right? This, I could say, can be considered also sort of a network bending technique. I mean, the thing is that here we don't really do anything with the network. We're just like unconditionally generating sound, but the network remains sort of untouched. What we are really changing is the codes that are being decoded by the network. So I'm just presenting the basic features. Then we have this randomize button and slider that allows you to kind of select the range within which the sliders will be randomized. It can be kind of useful to just play around. You can set how long does it take for the sliders to arrive to the new position. Yeah, but I wanted what is the core of the bending is basically this interface here that is all based on this 3-4 commands that I have shown you. So let's load the some sample once again. Let's do it again. Rhythmic sample. Here we can hear it. In this case, in order to drive the network, we have to drive the network by sample. We have to select the encoding trigger. So what is happening right now is basically the network is trying to interpret the incoming signal within its manifold of sonic possibilities. So as it was trained on human vocals, it's gonna translate any sound you pass through it into human vocals. But I guess that's not explaining this is not the point of this video. This is how rave works. There's lots of videos online on rave where you can kind of learn more about this idea. Here again, I just wanted to present you the bending. So once again, we can list the layers. In this case, they get a bit. You get like a bit better representation. I mean, there's just new lines, so it's more readable. And we can start playing. We just choose. I'm just gonna play around for a moment, so you see, I guess, the process. I'm just really screwing around. I have no idea, but that's kind of the spirit. And sometimes this can happen, which can also be nice. What's cool about it is also that once you arrive somewhere very far from the original behavior of the network, you can also kind of shift the representations in the latent space, and they're also gonna be interpreted differently. So that's just extra space for improvisation here and exploration. Okay, I think that's enough with this model. I just want to show you one more thing, because Rave originally, I mean, some of the Rave models, they have so-called prior built in. Prior is just like a second model within this like packaging of the TS object that allows you for the unconditional generation. And I think one nice model to play with is NASA. It's by the way, all these models, I think the Rave models, you can easily download from this site. So I'm gonna change here all the references to the model. What I'm gonna have to do here is also connect this message out, because NASA is a monophonic model as opposed to the VCTK. I'm gonna just, I think now I don't really need to reload it, but I'm gonna do it. I'm gonna restart here. I'm gonna stop the encoding and let's just listen to the NASA model when it's not driven by anything. So we are just generating the same latent code over and over. When I shift it around, you can see that the kind of quality of sound is changing. But what's interesting here is the prior. So once I enable the prior, the model is gonna be driven by the prior. And here we have the temperature, which basically controls kind of like the randomness, let's say, of the generation. I really don't want to get like too much into the details. Anyways, now we have some nice generation. And let's list the layers. What I want to show you here is how you can play also with the prior weights. So you're not gonna be really changing the quality of sound, but you're gonna be changing the way the sound or the generation is being driven. Once again, it's all about just experimenting. Interesting thing to play with is also the ablation, so just zeroing the layers. I think that's probably enough for the demonstration. I hope you take something out of it. I just also want to mention that there is one more thing that I showed at the workshop. That is basically how to create your own models, not rave models, but the DSP models based on research that I'm doing on small dataset models that are easy to train, that leave enough creative possibilities to experiment with. And I think I'm not gonna really go through this in this video, but I'm gonna create a separate one. But if you feel adventurous and just want to play around yourself, then there is this section in this link that I will leave that talks about this process, and there is a notebook that is kind of guiding, like, it gets you through the process quite explicitly and extensively explaining stuff, but nevertheless I'm gonna create a video on this because I think it might be interesting for you as well. Well, that would be it. Thanks.